All right, this is going to be our flipped classroom video for lesson 12.5. Now, I had made a series of earlier videos on this topic using the PowerPoint, but when I looked at what the practice and certify was, I realized I was giving too much information, and we're going to stick particularly to what is needed for this lesson. So let's go on. So we'll look at each example, and what I want you to include in your notes is the background needed to solve a particular example. Now, as background, I'd like you to include in your notes this formula: y equals ax squared plus bx plus c. Now, you may have written this before. This is the standard form of the quadratic equation in solving for y. Now, when we make a t-chart, let's say, and we put in various points for x, and my pen's not working too well, we're going to get a graph. And the shape of this graph is going to be a parabola, which I will draw shortly. Now, if our a term here is positive, the parabola is going to open up downward like so. And at the bottom of the parabola, there's going to be a point, and I'm just sketching here, that's called the vertex. And this vertex, since it's a positive value for a, is going to be the minimum. And minimum, I'm not going to use my pen too much, it doesn't write well. The minimum. When a is positive, the vertex is the minimum. Now, the vertex is written as an ordered pair, x, comma, y. Now, continuing with background information, and again, take any needed notes on this. If our a value is negative, then the parabola, instead of opening upwards, opens up downwards. Now, the top of it, that point right there at the top, if I can get a dot there, is the vertex. Now, if a is negative, the vertex is the maximum. And you can spell the rest of that out, indicating that's as high as it will go. So if a is positive, the lowest point on your parabola is the vertex and is referred to as the minimum, and they're given as an ordered pair. If a is negative, when it's in its standard form, the vertex is given, again, in an ordered pair, and is considered the maximum. Okay, so this is some background I should see in the beginning of your notes for this particular topic. All right, let's get back to our lesson here. We're going to give a little more background, actually. Now, some other things. As we look at the parabolas, and there's the word right up there, we notice that the line of the parabola crosses the x-axis right there, and also the x-axis right there. Now, what is the value of y? If I can get a dot there, right there anyway, what is that value of y? Well, y at this point is equal to 0. Y is 0 right there. So when we draw a parabola and it crosses the x-axis, again, y is equal to 0, these are the x-intercepts. Can't make a dot with the pen here. Intercepts. And I'm having trouble with the e's too. So these are the x-intercepts when y is 0. This is also described as find the zeros. When you solve this equation for y is 0, which we've done in earlier lessons, you are finding the zeros of the parabola. That's terminology that you should have. And I'm sorry about my pen not working that well. Now, one other thing you might note. How about, these are the x-intercepts. How about the y-intercept? Now, when x is equal to 0, what value we have right there is the y-intercept. So these are all things that we've done already. We have solved this equation and found the x-intercepts. That's when y is 0 here. And we've also found when x is 0 what the y-intercept is going to be. So again, hopefully you've added this to your notes and your pencil or pen is working better than mine. All right, let's go on. And still a little more background. So here is my x-axis, here is my y-axis. Here our a value is positive, it's going to open upwards. Our a value for this parabola is negative, so it's going downwards. But we notice what's on one side is sort of the same as what's on the other side of the y-axis. Well, when this occurs, what's on this side is the same as what's on that side. The line that runs down the middle is called the axis of symmetry. So you want to write that word down, these words, and kind of be familiar with what it's describing. Because they will ask you, what is the axis of symmetry? Well, when you find the vertex, which we're going to do shortly here now, whatever is in the x position when we find the vertex, whether it's the minimum or maximum, whatever that x value is, that is your axis of symmetry. And that's written then, x equals, and as in this case we see the value for x here is going to be 0. So whatever your x value is, that is your axis of symmetry. They're going to ask you that. And that's what you tell them after you find the vertex. Whatever's in the x position, that is your axis of symmetry. And for this one, as you'll see later on, I've worked this out already, and you'll see me work it out shortly, that our vertex is 0, -3. Now our axis of symmetry is going to be 0. All right, now we'll get on to our slide. So we'll think of this as example 1. It's in 5 parts, so you take notes on each part. Now in this part, they're asking us to find the vertex. So again, background information, write this in your notes. We'll call this example 1 as I mentioned. The formula for the vertex is negative b over 2a. This actually is part of the quadratic formula. So let's define our terms. What is a here? A is negative 4. Now remember, since it's a negative, this parabola is going to open up downwards. And when we find the vertex, that's going to be our maximum up here. So a is negative 4. What is b? Well, there is no b. So b is 0. So this is sort of easy. If b is 0, this is just 0 here, divided by negative 4 times 2 is a negative 8. But 0 divided by any number other than 0 is 0. So our vertex for our x value is 0. Put that over here. Now, what is our y value going to be when x is 0? Well, x squared times negative 4, x squared is 0. 0 times negative 4 is 0. So our y value, y equals a negative 3. And that's our vertex. Now, what is our axis of symmetry? Well, we said that already. Whatever is in the x position of the vertex is your axis of symmetry. So x equals 0. All right, now let's go on. So step 2 is to find the axis of symmetry. And we said that whatever in our vertex was in the x position, that's the axis of symmetry. So x equals 0. And we got that right. Now, the next thing, they want us to find the x-intercepts, if any. Well, for this, we need to study it a little. So we said our a value was negative here. So this parabola is going to open up downwards, and we said the vertex was 0, negative 3. So it's going to look like so. So are there going to be any x-intercepts here? Does this parabola cross the x-axis? And the answer is no. So there's going to be 0 x-intercepts. That's not always going to be true because, again, if you solve this, you'll find your x-intercepts, your zeros, that will be used in other examples. So you will click on the zeros and submit your answer, and they'll say, yes, that's right. It doesn't have any. And then we're going to go on to the next. And then it's going to determine 2 points on the graph of the parabola other than the vertex. We don't have any x-intercepts so far, so we have to determine 2 other points. So the strategy for this would be to make a t-chart. And now we're going to just put randomly 2 other points. Now let's use a 1 and a negative 1. We're going to put that into this formula and then solve it. Now I'll give you a chance to do it too, but I'll do it as well. Okay, I did some of this mentally, but let's just do it together. So x is going to be 1. So this is negative 4 times 1 squared minus 3, and negative 4 times a negative 1 squared minus 3. We're just finding some values for y when we put in an x value. So 1 squared is 1. So negative 4 times 1, this is a negative 4 and a negative 3, which will give us the negative 7. And if it's a negative 1 squared is still a positive 1. So this is negative 4, negative 3. So our other 2 points, I'm going to put these in here now as an ordered pair. Let's see what we get. So our ordered pairs in parentheses 1, comma, negative 7, negative 1, comma, negative 7. Submit answers, and we have it. Good. Let's go on to our next part. Again, hopefully you're taking some good notes here. Now, here we're asked to actually do the graph. So I like this part that I'm actually going to be able to show you. So we're going to move this, grab hold of it, and drag it down to this point. And then we said that negative 1, negative 7, I'm going to grab this side and move it down there. So there's 0, negative 3 as our maximum. Remember, our a value is negative, so it opens up downward. And then we said negative 1, negative 7, and then it pulls us to the other side. So there's our graph. And then we submit our answer, and we got this right. So that was just one example. Lots of material, lots of background. But now we should move on a little bit more quickly because we know what we're looking for. Now we're going to find all 5 things of what they asked us to do here. So first they want us to find the vertex. So our vertex formula is negative b over 2a. And you should write that down again. So what is our b value here? 4. So that will be negative 4 over 2a. A is 1, so that would be 2. So our x value here is going to be negative 2. Now keep in mind that's going to be our axis of symmetry too. X is going to equal negative 2. But we still have to find out what our y value is. Now notice our x is positive here. Our a term is positive. So this is going to open upwards somehow, wherever it looks, just to give you a little background. So now we know that x is a negative 2. What will y be then? Well, we do our substitution. So this is going to be negative 2 squared. So my pen's not working well. Let me get back here. Okay, if I write slowly, it works a little bit better. So I'm going to substitute our x value into this equation. So x is negative 2, which is what we have right here. So negative 2 squared is a positive 4. Now 4 times negative 2 is a negative 8, and then we have a 6. So adding this up, we get 10 minus 8 is 2. So our vertex here is going to be a negative 2, comma 2. So let's put that into the system. So negative 2, comma 2, submit answer. All right, we got that right. Next. Now they want the axis of symmetry. Well, we did that already. It's whatever's in the x position of the vertex. So this will be x equals -2. And we got that right. Now we want to see what our intercepts are going to look like here. So I'm going to take off some of this and show you what the graph sketched is like a little bit. So sketching this, our vertex we said was -2, 2. Still have trouble with my pen here. And if I put that on a graph, remember that's A is positive here. So this is going to be a parabola that opens upward. It doesn't reach the x-axis. So there are no x-intercepts. There are no zeros. So we're going to click 0 as a value here. Let me do that. So we'll do it live. And we submit that, and they say we got that right. Again, we made a little sketch to help us visualize what this is all about. And now it wants us to plot two other points. There is no x-intercept. There's a y-intercept, but that's okay. We're going to find two other points, and we're going to do that by, and as you do it with me here, making a t-chart, x, y. We need two other points. Now, so far we had a -2, and there's my pen acting up again here. Let me get back. So we have our vertex here. We want to find two other points. So again, pick small numbers. I'm going to do the substitution, and notice that when we square a negative, it doesn't change anything, but it does apply here. So we have to write it out twice, and I'll do it, and then you do it too. So let's check these out here, and again, substituting carefully. We did things like this earlier in the course. Squaring a negative still gives you a positive. And then -1 times 4 is -4. So this is 7 minus 4 is 3. And here this is just 1 plus 4 plus 6 is 11. So these are the 2 points I'm going to include because we're going to have to graph this here shortly. And when I put them into the system, it accepts it. And now we're asked to graph a little bit. So I'll take this off, but hopefully you have it in your notes. We're going to drag this now to its vertex, -2, 2. So -2, 2. And then we can use one of our points, -3. One of the points we had, and -1, 3, right there. Now, had we done -4, we would have gotten 3 also. So there's our axis of symmetry, x equals -2 right up there. And let's go on. Okay, here's something a little different. Now again, we worked with this formula before, but let's just look at it a little bit here. Got a nice blue screen there for a moment. And what do we note about it? Well, as we look at this formula, we see that our A term here is negative. And therefore, this parabola is going to look like this, which we know when we shoot an arrow, or whatever up into the air, a ball or something, there's going to be a high point up there. Again, I can't draw a point very well. And then it comes back down to the ground. Now, if we solve this equation with h being 0, that will be the total time it will take for it to be shot and then reach the ground. But that's not what they're asking here. They're asking, how high will this go up? So what we need to do is find the maximum of this. Since A is negative, our vertex is the maximum. So let's, again, find the vertex. V equals negative B over 2A. Now we know our A is going to be a negative 2 times 16. And our B, our initial velocity, is going to be 100. So let's take some time to work this, and I will do it. So that's a negative B. So it's a negative 100 divided by a negative 16 times 2, which is a negative 32. So this will become a positive here. When we do our division, we get 3.125. They want us to round it to 2 decimal places. So when it's a 5 in the 3rd decimal place, we drop the 5 and make the 2 a 3. So I'm going to put in there a 3.13, and let's see what we get. And they say I got that right. Okay. Now, what will the maximum height be? Okay, well, we need to find our y value here, because we found the x. Well, we're going to put this into this equation with 100 being there and see what we get. Someone's calling us on the phone. Okay, so I've put the value of x, 3.13, into this equation, and here this was just 0. And when I rounded it off to 2 decimal places, and you should try this as well, we get this, and this is correct. So the height will be this many feet in our parabola. Again, we're showing you what this looks like here. Y is, getting some crazy things with my pen. I'm going to see if I can fix it. It didn't used to give me this problem here. So this point up over here has the value of, our x value is 3 point, it's not making a dot there, 1, 3, comma, and then 156.25. Again, I'll have to work that out. Okay, well, we're going to pause here, or my wife's calling me for lunch, actually. So now in this next example, we're going to take a look at a store owner that's going to charge X dollars. If he can sell this many lamps, what will be the price of the maximum revenue? Well, we have to find out what our equation is going to be first. So it'll be X times this, and I'm going to put the negative X first so that it looks like this. Negative X squared plus 15X. Okay, so with this, can I find out? This is a parabola. Our A value is negative, so this is going to go up like so. We're looking for the maximum. So our vertex formula is V equals negative B over 2A, and that's going to be a negative 15. There's our B, and our A is 1, so negative 2. So this is, when we reduce it, 7.5. So $7.50. Again, I apologize for my pen not working very well here. Let's put that in there and see how we're doing. 7.50. And we got that right. And it says we've finished. Good. All right, we'll keep this lesson just a little bit short. Hopefully you have now what you will need to do well on your practice and later the certify for section 12.5. We've cut down a little bit on it, but I think that'll be good. All right.